Okay, algebraically determine the equations of the asymptotes to this thing. We're going to need to know where this expression can equal 0 or when its denominator can equal 0. So the first thing you want to do with a question like this is factor the expression as much as possible. Now, I believe the numerator factors to x plus 3, x minus 2, x squared minus 2x plus 3x minus 6. Yeah, that's good. And I would normally do decomposition on this denominator, but I'll see if I can just freehand it to save us some time. 2x squared would come from 2x times x. Here I need a 1 and a 3. I think I need plus 1 and minus 3. 2x squared plus 2x minus 3x. Yeah, that's the stuff. Okay, so obviously there's many ways to factor this. Decomposition is the best one, but I decided to do it fast and loose to save a moment. The point of doing all this is, if you have a rational expression, its denominator must never equal 0, because that would mean we're dividing by 0 and we don't know how. So if our denominator ever equals 0, then we are in trouble, and this expression will be undefined. Can it ever equal 0? Yeah, it can, in two different situations. Either 2x minus 3 could equal 0, which would imply that x is 3 over 2, or 1.5, or this other piece could equal 0, which would give us x equals negative 1, and there again the expression would be undefined. So both of these are what we call non-permissible values, and as long as neither of them can be cancelled out, 2x minus 3, nope. As long as neither of these can be cancelled out of the original expression, then you can expect to see an asymptote. So if you graph this on Graphing Calculator, you should find that you get an asymptote at 1.5 and another one at negative 1. Let's see if that actually works. If it doesn't, I'll have some explaining to do. So here is a Graphing Calculator, and into it we put x squared plus x minus 6 divided by 2x squared minus x minus 3. Graph. There's an asymptote. There's another one. And let's see what we can see from our table of values. This is one way you can find an asymptote or a non-permissible value off the calculator, is if you look on your table of values and you find error, that means the expression was undefined there. So the calculator tripped up at negative 1. The trouble is here it's only checking every whole number, and so 3 over 2 isn't showing up. The other way you can get a look at this, at what's going on at this point, that sure looks like 1.5, but we'll make absolutely sure, is you can go to second trace, pick value, and now you can make it look at any x value you wish. I want 3 over 2. Enter, and the expression is undefined there, so it says y equals, and it didn't even say error, it just left it blank. That's the calculator saying I wasn't able to find an answer at the number that you gave me. So, yeah, it looks pretty good. The expression is undefined at negative 1 and again at 3 over 2.